Hello, this video describes the instructions for Homework 2C and Stat 312 data science applications. These are the instructions that lead into Project 2, which is a separate submission that you'll have to do using R Markdown. We won't go over that part in this video. This video will just talk about the analyses that are present. But make sure you read the instructions for submitting Project 2. You'll need a file from Canvas, that being a list of Shakespeare's works and their corresponding Gutenberg IDs. You'll need that in order to do this particular assignment, but when you do your project, you will make your own version of these files. Just for reference, what this file looks like is it's a table with 3 columns. The first column is the Gutenberg ID. The second column is name, which is the name of the work, so the title. And the last is the type of the work. Tragedy, comedy, or whatever. Okay, the focus on this particular assignment is to learn about Zipf's law, which compares the position of a word in a sorted list of word frequencies. So the most frequent word is in position 1, the next most frequent word is in position 2, etc. What Zipf's law says is it says that what you expect for the frequencies of these words is that they're inversely proportional to their position in the list. Generally, people call that position in the list the rank. So Zipf's law says that the word frequency is inversely proportional to its rank. So that's the first thing we'll do, and then the second is a TF-IDF analysis. What TF-IDF analysis does is it takes the term frequency, the frequency of a word, and compares it to the document frequency. Words that are very common in a particular document but not so common in other documents are really the interesting ones. Words that are common across all documents are not so interesting. They're probably things like stop words. This allows you to avoid analyzing by rejecting stop words. Okay, let's get to it. In order to do this analysis, we need a few libraries in hand. So let's load them up. You need the Tidyverse, and you need the Gutenberger library and the Tidytext library. Let's get those loaded. As before, we need to load the Shakespeare corpus, which is this CSV file that I've given you on Canvas. It's the same one that you needed for Homework 2B, so you should already have it. Here's where mine happens to be. There we go. Loaded it up, and we're ready to roll. Okay. Now, if you watched Homework 2B, you learned about loops and how to download the entirety of Shakespeare's work. I'm just going to put all that in my paste buffer so I can dump that in here. So here we go. Okay. We've got our book in hand. Book is a data frame with 2 variables and a lot of observations. Each one is a line from Shakespeare or the book that it's from, so there's some header information in there too. If you want to strip that out, be my guest. I'm not going to do that for this particular video. Great, so let's tidy things up a bit. As has been done in previous videos, what I'm going to want to do is tidy it up by unnesting tokens. And getting word counts. I'm going to group by Gutenberg ID. So if you do this particular task, you'll see words counted according to Gutenberg ID. So the appears in Gutenberg ID 1122, 11,000 times, etc. What we've done by doing the count in this particular way is we've stripped out a lot of the other information that was present in the Shakespeare corpus. Let's do a merge. Let's merge in by an inner join the information we want. And we'll join by matching up the Gutenberg ID columns. Okay, there we are. So you can see pretty much the word "the" appears in Hamlet, Prince of Denmark, which is a tragedy. It occurs 11,000 times, or 1,100 times, 1,163 times. Great. Okay. Now, one of the things that that we want is the total number of words when we're doing our analysis, because we're going to be normalizing by the total number of words in each of these various works. Group by is your friend here, because group by controls how things like sums work. So we want to sum up each of these n columns. We want to sum them up grouped by either the name or the Gutenberg ID. They should be equivalent, and in fact they are. So group by name, and then when we do our sum, the sum will pay attention to those groups. We summarize them using a column which we'll call total. Like so, and what did I do wrong? Oh, that wasn't Shakespeare corpus, it was supposed to be Shakespeare words. Oops. There we go. Okay, great. It gives you a harmless warning reminding you that it's ungrouping once you've done your group. That's fine by me. If we look at the total words, you'll see this is the total words in each of these various documents. Fair enough. Now we want to merge this back into our Shakespeare words column. So let's do that. And you could use an inner join because you're guaranteed that all the names match, but it's just slightly safer to left join in the two. Let's left join the Shakespeare words and the total words. And there they are. So now you can see, all right, "the" occurs in King Henry Richard 1,012 times, and that entire play's got just shy of 32,000 words. Okay, fair enough. What we're going to be doing next is we're going to be doing some word frequencies, so we need to do a little bit of normalization. Normalize by the number of words. So for instance, let's do a quick histogram plot. Let's only look at the tragedies. One of the things that happens because Shakespeare was a prolific author is that if you try to plot every which way all sorts of things, you will very quickly run out of space in your plots, and it'll get cluttered. And one of the things that I think is good to do when we're doing this is to, rather than letting R figure out how to organize them in the plot panel right here, I think it's useful to say, hey, I want 2 columns of plots, because otherwise they won't fit. You can do that with a facet wrap. And how do we want to organize things? Well, we want 2 columns, and we want to organize them by name or versus name. Tilde is versus, so let's do it by name or versus name. And no, it is capital name. And I spelled A-E-S, A-E-X. Oops. There we go. Harmless warning reminding us that maybe we want to tweak the number of bins. Yeah, sure, that's a reasonable thing to do. But you can see that there are a small number of very frequent words, and the less frequent words, there's quite a bit fewer of them. You can mess with the plotting to your heart's content, maybe turn off this legend to give you a little more room, maybe mess with the scales and the colors and what have you, bins, etc. I will leave that in your capable hands. Now, if we want to do Zipf's law, what Zipf's law says is it says that these curves ought to be actually an inverse proportionality relationship, i.e., position in this list ought to be inversely proportional to the frequency. Well, in order to do that, it's handy to organize the words a little bit by sorting the words by rank. What I find very, very useful to think about is that, again, group by is the magical tool that you're going to want, because group by allows you to say, well, if I notice these guys are sorted by n already. They're already sorted by n. So if I go for the first the, that's rank number 1. That's the most common word. So is this guy. This is also the most common word. They're just most common in different types. If we group by type, then the order in which they appear in this list, grouped by type, will be the sorting by rank. So if we group by work or group by name, then add a new column, a rank column. Mutate will add us a new column. We could just say, actually, group by row number. You would say, well, row number, my gosh, row number's right here, right? How useful is that? Not very useful. Except for the fact that because row number is sensitive to grouping, it will say this one gets rank 1, and this and, which occurs in actual row number 6, gets rank 2. All right. Let's do that, and let's take a look at what that data frame looks like. Indeed, just as claimed, the rank does not go 1, 2, 3, 4, 5, 6, 7, 8, etc. It pays attention to the groups. That's pretty useful, and that's pretty important. Okay, so one thing we'll want to do is we really also want to know, we want this normalized. So let's normalize the numbers based on the total. Okay, we need to add another column to that. All right, fine. Let's just add another column by extending the mutate command to build a frequency column. And one thing that's helpful at this point is just to ditch the groups once we're done, because we'll do summarizes and things like that. We don't need the grouping anymore. All right, crunch, there you go, and you can see the frequencies, which is the ratio of the n versus the total in each row. Fair enough. Let's plot it. Let's plot the rank versus the frequency. And Zipf says that this guy ought to be a 1 over x kind of relationship, inverse proportionality. Traditionally, people like to show 1 over x relationships not on linear scales, but on log scales, because then they become straight. And neat enough, ggplot2 lets you change the scaling by decorating after you've packed up your data. So the scale x's and the scale y's at the end there force the scale to become logarithmic. Let that chunk a bit. And be patient as it plots. And yeah, I see a bit of a linear relationship here. Now, all of this is spurious information. It's not really very helpful. Let's turn it off because I don't need it. There we go. And yeah, there's a nice linear relationship that looks pretty close to being a slope 1. That is the Zipf law in action. It deviates a bit over here. These are the very frequently used words, so maybe Shakespeare uses a little fewer thes and ands than Zipf might suggest. Fair enough. And then down here, it sort of peels away a little bit as the reason is you just get so few hidden instances of each of these words that it really isn't so statistically significant anymore. Okay, this looks like a straight line. How do you tell if you got a straight line? How do you tell what the slope of that straight line is? Good old linear regression. So R makes linear regression really nice to work with. It's the LM command. And even more than that, it can handle the fact that your words might be, or the things you want to compare, the variables you want to compare your linear regression with, need not actually be just columns. They can be algebraic transformations of columns. In fact, we're interested in a linear relationship between the log 10 of frequency versus, there's the tilde, not the minus sign, that's a tilde, versus the log 10 of the rank. Cool. The data is words by rank. Run that linear regression, and it says, okay, well, I see a slope of minus 1 point change. Hey, Zipf would say that should be 1.000. Not too bad. Not too bad. You can go ahead and add a line to this plot. That's kind of convenient if you go ahead and store the output of this linear regression. LFIT, I'm calling it. It's a list of numbers, and it's sort of awkward to work with. But what it's got built into it is it does have the coefficients. So if you say LFIT coefficients, it's got an intercept and it's got the log 10 rank. So if you want the intercept, sorry, this is really grody because it's a textual string to do the indexing, but there it is. And if you want the rank, of course, you can get the rank by doing log 10 rank. Fair enough. So I want to add this line to my plot. How do I do it? Well, here you go. Here's how to do it. Just insert an AB line. Because when you insert an AB line, you can tell it the slope and intercept. The intercept should be LFIT, $, LFIT, $, coefficients, brackets, intercept, and the slope. Well, what's the slope? Well, the slope should be LFIT, $, coefficients, bracket, log 10 rank, close. And let that chunk on it a bit. It's just adding that line to your plot. And there's that line. Shrunk right through there. Pretty darn good fit. Yeah, it deviates a bit on the very high frequency, low rank words, the very common words. That's not unusual from what I've seen of Zipf's law. Okay, now on the other side of things, let's take a look at the analysis that you can do about finding the most interesting words. These are words that balance being very frequent, yet not being common across documents. So if you take a look at the word the, you'll notice the is top of everyone's list. Probably not a very informative word. On the other hand, if you find the word, say, oh, well, you got to kind of go down pretty far to find it. Find the first starting interesting words. Where are they? Maybe, oh, I don't know. Wow, there's a lot of them down here. Macbeth. Okay, so finally you start to hit words that Macbeth shows up in Macbeth, but I can pretty much guarantee Macbeth, although it shows up a lot of times, 286 times in Macbeth, it probably doesn't show up in any of Shakespeare's other works. That's an indication Macbeth is probably an actually important word in the play Macbeth. The idea of this is to include not just the frequency of the term, i.e. the N, but also sort of downweight it based on how many times it shows up in other books or other works. Now, this sounds very complicated, but the Tidytext library already provides this capability. And you can add a few more columns to your data set just by a single call. So let's go back and look at this Shakespeare's words by rank or whatever you want, and it just does it. In fact, it can do it without even having a whole lot of analysis done. So here we go. So what you feed it is you feed it the Shakespeare words, and you say bind TF-IDF. We're going to bind based on word across types and use the N column. And in so doing, you get a data frame that now has the TF, the IDF, and the TF-IDF column. The one you really care about is this last column. If you sort by this column in descending order, you'll hit the biggest, baddest words first. Okay. Now, you might ask, well, gosh, I'd like to sort them. Can you sort them? Sure. And actually, it's kind of easy to sort them by rearranging the data set. So by asking, this is a nice tidyverse command, to say, I want to rearrange the rows. And how do I want to do it? I want to put them in descending order by the TF-IDF column. And there they are in descending order. You'll notice, hey, Macbeth is probably the most important word in Macbeth, because Macbeth doesn't show up in any other places. Same with, hey, the name of the lead roles in most of the other plays. Pretty nice. Now, if you want a smaller data frame to just look at some of these words, not all of them, one way to do it is with the slice. So you can say Shakespeare TF-IDF. Let's group by name. And let's slice off the max, the largest, the TF-IDF columns, n equals 10. Oops. And what did I do? Oh, I forgot a pipe. There we go. So you can see the top 10 from A Lover's Complaint, which is poetry, are leveled and seamed and applied. The 1137, why does that? That's an artifact. Because this is Project Gutenberg and I didn't get rid of all the headers. Sorry. Okay. Now, to finish this off, you can make a nice plot of word frequencies, or TF-IDFs, for each of the words. It's done pretty much the way you might expect. So start out with the same kind of instance. In fact, actually start out practically with the same kind of thing. Let's filter by type. Let's take a look at just the comedies so things don't get too cluttered. And let's ggplot this guy. Versus word, and fill equals name. And if you do a geom as column, you'll get a nice histogram-y kind of thing. There's too many of these to really fit on one plot, so I'm going to do a faucet wrap. Versus name. And what did it not like? Oh, I spelled comedy wrong. Okay, and there were no columns. And I can't spell name either, apparently. Too many typos. And sort of be patient because this is doing a fair bit of processing for you. Okay, and there they are, and they don't look particularly good because all the scales are the same. So let's make the scales be different. That cleans things up a bit. And you can see definite histograms showing up there. It's kind of still a bit of a mess if you dial back the number of words from 10 down to, I don't know, 5 or something. It looks a little nicer. And there you go. So you can see the main characters showing up in each of these plots being kind of frequently, and actually the size of the bar is kind of suggesting who's the most important character. So there you go. That's the end of the analysis for Zipf's law and TF-IDF analysis in the text mining module. At this point, you should follow the instructions in Homework 2C to create an R Markdown document for a bunch of works of interest to you. You can dig around on Project Gutenberg to find a bunch of works, follow the instructions, and of course, feel free to drop me a line if you have any questions. Thanks for watching, and I hope it was useful.